All right, hello. This video is going to be reviewing Chapter 7, Logarithms and Exponentials. In this video, you might see some weird questions and stuff because normally in class I do a speed dating activity. These are how most of my speed dates went. But anyways, just if you see weird questions in the video, that's why. What's on the Chapter 7 test? But the huge thing, again, we've talked about switching between the two log and exponential forms. You have to know how to do that. The interest, remember there's two different interest formulas. If it says continuous interest in the problem, you'll be using this interest formula, and if it doesn't, you can just assume that it's annual interest, this formula here. And then a bunch of logarithm stuff too, where you have to like write as a single log or expand. Those are those properties, that 7.4 properties. And then you'll have to solve for sure. So there's two different types of solve ones when they start in exponential or they start in log, right? So that's the final thing that's on there. So not a ton of stuff. It's just 7 sections, 7.1 to 7.5. So it's not a ton of stuff to get ready for. Okay, so again, these are the date questions. You can basically ignore those. But so change of base formula, right? If we want to evaluate this log, please note the language here. Like you can solve this one by what I call switch forms. So like this one says like, 5 to what power will give us 125, because log means find exponent, so our answer here is 3. But that's not the change of base. Change of base is something different. That's what I call switching forms. So see if you can remember what change of base is. Okay, so change of base is really good. If you can't do it mentally like this, you just type in your calculator log of 125 over log of 5. And basically this number goes up and this number goes down. And what you have, why it's called change of base, is now you have 2 base 10 logs. Okay, so you can just do those on your calculator because the calculator button is base 10. So you just type a log of 125 over log of 5 and that will evaluate to 3, right? And that's why it's called change of base. Okay, and then I think they do have the generic version of this. So you just have to know that like this number goes up and then the little base number goes down. So this one would become log of m over log of p. Okay, and I'm not going to write in the little base 10s. It's sort of like an implied base 10, but basically this thing is equivalent to this because of the change of base formula. Now you have 2 base 10 logs instead of a single base p log. Okay, and I should have said this earlier too. You should always try these before like watching the solutions, right? So here's a couple more interest ones for you to try. Pause the video, reference the 2 formulas, right? Hopefully you have them written down somewhere. They'll be given to you on the test, but for this review, write them down. So try these 2 and then unpause the video. All right, so first thing is to realize that they don't say continuous in these at all. So in fact, it says annual here, so we're going to be using this formula for both of these. Okay, and then part A is kind of the straightforward one. We want to find the amount after 3 years. And so we start with $500, and then we do 1 plus the rate as a decimal, so move this over twice. So it's 0.017 to the 3rd power. Okay, so really if we clean that up a little bit, we can add those together. So we get 1.017 to the 3rd times 500, and then I just crunch all that on my calculator. So 500 in parentheses 1.017, little hat thing, and 3rd power, and so we get about 525 and 94 cents. So 525 and 94 cents. Okay, and I would always make sure if my answers make sense. This is not a lot of interest, just a little bit less than 2%, and it's only 3 years, so we made $25 interest. Yeah, that seems reasonable. All right, this one is actually going backwards. Okay, so we want to find the amount. We want to find this A of t. So we want to say when will the amount be $1,354. And so the rest of the formula we do 800 as our starting, and then 1 plus the rate as a decimal. So move it over twice, 0.049 to the x power or t power, or however you want to do it. Okay, and so now there's actually 2 ways to solve this. You can use the y equals. Earlier in the chapter, we used like the y equals screen on our calculator to figure this out when it equals this number. But honestly, at this point, I think this is a lot better to solve with logs, right? Since we know how to do that at this point, this one is an exponential equation, so we should be able to solve it with just logs, right? So my first step would be to divide both sides by 800, right? Because I want to isolate this part. So I'm going to divide by 800. So when we divide by 800, we get 1.6925 equals 1.049 to the x power. Okay, now we've isolated this base exponent, so now we're just going to switch the forms, right? So remember when you solve, you always switch forms. So now I'm going to switch to the log form, right? So I'm going to write log with my base being the 1.049, that's my base, and log means find exponent, so I put my exponent over here, and then my other thing is the value. So it's a lot of little decimals there, but now you just type this in your calculator, right? Log over log, that's the change of base formula, and you'll get your answer. So I'm going to do, let's see, the log of 1 point, I forget what it was already, 1.6925 divided by log, and then my other number was 1.049. Okay, and then enter. And so that looks like if we round it, that's going to be like 11 years. Okay, so basically it's going to take us 11 years to get to that amount that we want. And again, that seems reasonable, right? We started with 800 and we have to get to a pretty big number, 1,354. So the fact that it takes 11 years is not all that surprising. Okay, so these are the properties, right? So how do you clean this up with the log properties? We want to have a single log when we're done. So it looks like this is a base 10, even though it's not written there. It's a base 10. So pause the video, see if you can use your properties to clean all this up. All right, so first thing is these numbers in front are going to become exponents. All right, so I'm going to write it as a log of x to the fourth plus a log of y squared minus a log of z cubed, right? So that got rid of all the numbers in front. And so now I'm going to write it as a single log. These two things are going to multiply because of the add. So I'm going to have x to the fourth times y squared. And then this subtract makes us divide. So we're going to be divided by z cubed. And that's all cleaned up into a single log. All right, so just use your properties. Add, you multiply these two parts. I should highlight them for you. Multiply those when it's an add, and when it's subtract, you divide the parts. Right, and then the only other thing you got to remember again is bringing up those numbers or bringing them down if we're going the other way. Okay, one more single log one. This one's a base 3, so our answer is going to be like a single base 3 log. But if it, if it freaks you out, you can just kind of ignore the 3 and just put it in at the end at your answer. But anyways, here we go. Try it first. All right, so it's just like the last one. We're going to bring these up first, right? So we're going to have a log base 3 of x cubed minus a log base 3 of y to the 6th. And then keep the base 3. And now just basically because of subtract, we're going to divide these two parts. So we're going to have x cubed divided by y6. And that's it. Now we're a single base 3 log and we are done. All right, so solving one. Okay, so remember you want to isolate the log or the base exponent and then switch forms. So this one is log form, so eventually we're going to have to switch to exponential. Pause the video, give it a shot. The log is already isolated, right? Its base is 10, so we can actually switch forms right away because this whole thing is log, right? So I'm going to say, okay, my base is the invisible 10. I'm switching forms again. All right, and then my exponent is 2 since log means find me the exponent, and then I write the value 2x minus 5 on the other side. Okay, and that's really it. If you can switch forms effectively, this is not that bad. 10 squared is just 100, and then add 5 to both sides, divide the 2, and that would be 52 and a half. Right? And that will be our answer. Okay, another solve one. All right, a little bit trickier this time, but eventually, again, we're going to be switching to exponential form. So pause the video, give it a shot. All right, so to get it as a single log, we have to use our properties. So I'm going to write as a single log, and then because of the subtract, I'm going to write 4x divided by 7. Right, these two parts end up being divided. Okay, now that it's a single log, I'm going to switch forms. Okay, and the base is again invisible 10. So when I switch forms, I'm going to have 10 to the negative 2 power, right, base and exponent equals the value of 4x over 7. All right, and 10 to the negative 2 is kind of weird, but you end up with 1/100th. And if you need help with that, just type it in your calculator. It's like 1 over 10 squared. So it's like 1 over 100. But anyways, from here, I'm going to multiply both sides by 7 to get rid of that divide 7. So we end up with 0.07 equals 4x. And then we'll divide by 4. And so x is going to be equal to 0.0175. Sorry, that didn't show up very well. That should be 0.0175 is my answer. Just couldn't get it to write very well. Okay, so that one was a little trickier because we had to use the log properties, but the idea is the same. Get it to a single log and then switch forms. All right, so exponential now. So now I'm going to go the other direction and pause the video before continuing. All right, so I want to isolate this base exponent before I switch forms. So I have to minus 12. So I'm going to write 16 to the 2x equals 1011, I think, if you minus 12 from both sides. Now I'm going to switch forms. Okay, so now that we have this isolated, I'm going to switch forms. So I'm going to write the word log. And I always do the base exponent first. So the base is 16. And log means find me the exponent. So this is our exponent, so it goes over here on this side of the log, and then the value goes here. Okay, and again, now I just have to do this side as change a base, and then divide by 2. So I'm going to do a log of that number divided by a log of 16. Okay, and then divide that result by 2. Okay, so I'm going to go to my calculator now. So I'm going to do log 1011. Close this, divide by log of, I forgot the other number, 16. Okay, so that's my answer, and then I just divide that by 2. All right, so because of this times 2 here, once I get my answer, I got to divide it by 2. So it's 1.25. All right, and that's it for this review. Thanks for watching.